integration property. So this is one of the important thing, guys. So I think up to last class we have discussed majorly on the Dirac distribution, so, sorry, impulse function. That is the some property over it, like multiplication, sampling, and everything. We have gone over the Dirac impulse pulse. So today we are going to continue that discussion with the impulse over the integration property. So we have already see when an impulse pulse is multiplied with any signal, that sample will be taken over it. So that is with the from here. So if you see the value at which the t is equal to 0, that will be taken there and it will be a constant value over there. So if we extend that observation, here I am taking the scenario where we are multiplying the x of t. So let me take a red color pen here. So this is a standard signal, maybe any signal that may be. So here we are multiplying the impulse signal with some time shifted impulse and everything is happening. So if we revise this and write, how this can be changed is that the integration over the time interval t1 to t2, the x of t. Now if we extend this one, then how this will be is that x of c by b. So this one we already discussed, divided by modulus of b. So this one, this b will be constant, this term will be constant, and this will be multiplied by the shifted impulse of t minus c by b. So means this will be the pulse. So c by b. So this will be the impulse pulse and over the time interval dt. Okay. So thing is that if the c by b, this impulse, so if this pulse is between these two interval, then only this output will be 1. If else, this output will be 0. So as we see, right? So this is, so let we are going to take a case 1. So let me take a blue for case 1. So here case A. So case A is that the time interval t1 is here and t2 which is here. So means if you see here, the impulse is not between these time tuples. So if it is not here, then this will become 0. So in case A, the output, let me take this as I. So if you take I, then I will be equal to 0. Because the impulse is not in the time period t1 to t1 only we are integrating. If the impulse is not there, then multiplication with the signal will be 0. So if even if it is constant, so this we know this is a constant. So even if we multiply the impulse signal over the impulse is not present in the time period, if we multiply, the area will be 0. So that is what the thing. So let me take a case 2. I hope you guys are able to understand things. So let me take a case 2. The t1 is here and the t2 is here. So if you see the impulse is between this area, so this value will become 1. So this value will be 1. So if we do that, then the case value I will be some constant. So what the constant will be? I will be x of c by b, that what is the value with respect to, divided by 1 would be modulus of b. So this will be value of the integration output. So let's take a case 3 that, so the t1 which is lying here. So for an example, t1 is lying here and this point itself is t2. So if that is the case, then what will be happening is that that case is invalid. So the case C is invalid because we may not know at that exactly at that, if a t2 which is equal to c by b, then we can't exactly resemble the things. So we can't make the things to be happen. So in that case, we consider the case as a invalid. Okay. So these are the three cases, guys. So integration property is very important. So you please remember the thing that the impulse pulse need to be at the same interval where we are going to consider the area consideration or integration consideration, everything. Okay. So I hope you guys getting the point. So if we are getting the impulse pulse which is already a function of another one value, so for an example, del of g of t. So g of t may be any kind of function. So if that is happening, how we can expand this thing is that, so del of t minus t1, so this is del of t minus t1 divided by modulus of g dash t1. I will explain what you mean by g and everything I will explain. And del of t minus t2 divided by g dash t2. This will continue up to the infinity. Okay. So thing is that, so g of t which is equal to 0. So we have to make sure the internal function which is equal to 0. Then what are the values we get, that is equal to t1, t1 comma t2 comma t3 infinity, like this way. So what are the values at which the function which is equal to 0, that we will be making sure. Okay. So let me take an example here. So we are getting del of sine t. Okay. So we know that del of t is a function where sine t is another function. So here the g of t which is equal to sine t. So we are comparing to the previous thing I have explained. So g of t which is equal to sine t. So if we make g of t which is equal to 0, we know that the sine pulse will be 0 at pi and also at 0. Okay. So at 0, minus pi, pi. It will continue in both the direction, right? So these are the interval over which sine t which will be 0. So if we write the equation like as we are seeing here, so if we make the things like this, then this will be I'm skipping, only writing three values. So del of t plus pi, so this one minus t I'm writing, so divided by, what we have to do is that we have to apply the t dash. So g of t we know that is equal to cos t, so sin t differentiation which is equal to cos t. So if it is odd pi, so if the pi is odd pi, then the value will be minus 1. If the pi is equal to even, then the value which is equal to positive 1. Okay, so it will be positive 1. Okay, so this is minus pi, so we have to consider this is the odd pi, so the value will come here as the minus 1 modulus plus. So when the t which is equal to 0, then this will be del of t divided by cos 0 which is equal to 1. Okay, plus 1, so we have to make modulus also. So if we take t is equal to pi, then del of t minus pi. Okay, I hope you guys able to understand, right? So we are making, just mimicking this one, so this equation we are mimicking. Okay, so divided by, so this is also odd pi, so this will be minus pi. Okay, so like this way it will go in this direction. So this is how we can able to solve any function which is inside the impulse function we can write. So we can draw a diagram for this. So let me draw a diagram. So how the del of sin t diagram will be looking like this, this will be like this way. So this will be like this. So the impulse functions will be, it will be at a t is equal to 0, so I am writing t is equal to 0 here, and the impulse is shifted here, which is shifted by pi, so I will write the pi here, and the impulse is also shifted by minus pi, so I will write this one also here. So like that way it will go in all the direction, both the direction it will go up to infinity. Okay, we know, right? So sine is the entire graph. So like this way only we can draw a impulse function for any function inside the impulse. Okay, so this is t, so this is 0, so this is pi, this is 2 pi, minus pi, minus 2 pi. So this function we call as a del of sin t. Okay, so this is how, even if they give any other functions, you guys can able to do the same thing. So any, if there is any function inside the impulse, we can use this rule. Okay, so I hope this is understood for you guys. So let's talk about the other things. So impulse function is completed, so from here we can conclude it. So next we can start with the step signal. Okay, so I hope the impulse signal is very good understood for you guys. So if you guys have any doubt, please post in the comment section, so that I will be there to solve those doubts. So here today we are going to start the next standard signal, which is unit step signals. So impulse is the first signal that we have saw, so today we are going to start unit step signal. Okay, so how the del of t which is defined is that only at the t is equal to 0 we have defined the things, so that is how it will work. But how the mathematical representation for the step signal which is equal to, which is u of t over the time period t. Okay, it's similar to x of t over the time period t. Okay, so we can take the analogy like this way. So we just name this signal as a u of t, as it is a step unit signal. So how the graph will look like is this way. So it's very simple. So it will be 0 for all the values which is less than 0, if it will be greater than for all the values which is greater than t, so greater than 0 for the t time interval. Okay, so let me draw the thing. So let me take a red color. So initially it will be 0 for all the values is less than there, and it will eventually get a step impulse, and it will be maintaining at 1 over the entire positive region. Okay, so this is how it will be. So this is t, so signal will trace like this way. So there are many analogies to understand this thing. I will explain each and everything, so stay tuned here. So it will be called as a u of t, that is a step impulse signal. Sorry, step unit step signal, not a step impulse. So u of t, it gives the step change at t is equal to 0. Okay, so this is the break point at which we can. So how we can relate this function is that u of t, which can be written in two way, that is 1 when t which is greater than 0, and 0 when t is less than 0. Okay, so from here we can clearly say the function graph is represented, or we can able to get the valid answer when t is greater than 0 or less than 0. But thing is that when t which is equal to 0, there is no standard definition to maintain. So there is three things that we can take into account. So what will be the value of step impulse at t is equal to 0? So here three scientists, three experts have gave solution to this. So first thing is that they're generally stating this is indeterminate. So we cannot state at what value it will be. So this is a general physical law that we have defined there. So what they're saying is that At a t is equal to 0, it can be at any value. Okay, we know 0 to 1, which may have infinite set of numbers. We can write 0.001, even 0.1, 0.111, like that way we can define many values, right? So it will be in any of the region which is the subset of 0 to 1. So like that way they are stating. So this is one application rule. Second thing is that a scientist have said that Gibbs, what he is saying is that, okay, from your case let's take it as an infinite number of sample, so let's average both the thing. So first value which is 0 and final value be 1 divided by 2. So he is stating that what will be the value of unit step at the t is equal to 0 will be, let's take this as a zero point 0.5, like that way he is saying. So some other guys have came. So what they are saying is that, why you guys are worrying about these things? So let's make this simple. So it will be 1 at a t which is greater than 0 and 0 when t is less than 0. So please include the 0 for the 1, like that way they are saying. So thing is that practically we can take any of these assumption, but if we go for theoretically we can take any of these assumption. For an example, if you are practically charging a capacitor, how it will charge is that it will slowly charge like this way, right? So that's why the assumption is coming that cannot state this one. So thing is that if what is the application that you are using, please make use of any of the three rules. So you can choose any one from here. So this is one, so this is two, this is three. So this may be you guys may think that is a normal thing, but there is a plenty of controversies in the step signal that is t is equal to 0. So in most of the gate examination, we will state that t, the third condition only we will take. Even if there is any changes happening, they will mention it in the question, so we can make use of those things. So we need not to worry about those things. So from here, I have given you some understanding of unit step signal. From next class, we will be kickstarting the properties of the unit step signal. So stay tuned, guys. Like, share, and subscribe the channel. So stay tuned and motivate me to post more videos like this. I hope the impulse is very good for understood for you guys. So next lecture we will be completing the unit step signals, and then we starting with the ramp and the parabolic signal. I will make it short and I will explain all the concepts also. Don't worry, I won't skip any technical parts or anything that is needed for you guys. So I will make sure everything is corrected in a correct way. Everything is taught in a correct way. So please like, share, and subscribe channel. Stay tuned, guys. Thank you. Let's meet in next class.